Okay, so this is chapter 12, number 11. A 15-meter uniform ladder weighing 500 Newton rests against a frictionless wall. The ladder makes a 60-degree angle with the horizontal. A. Find the horizontal and vertical forces the ground exerts on the base of the ladder when an 800 Newton firefighter is 4 meters from the bottom. B. If the ladder is just on the verge of slipping when the firefighter is 9 meters up, what is the coefficient of static friction between the ladder and the ground? So first, I drew a picture for part A. So you see here, this is my 15-meter ladder. It's at a 60 degree with the ground, and there is the firefighter, and he's only 4 meters up from the ladder. And then we have the 500 Newton, and I put it in the center of the ladder. We see a force exerted against the wall, which would be this way. And the wall will be pushing a force this way. And the ground would obviously be pushing upwards like a normal force because we have the ladder making contact with the ground downwards. Okay, so for the equation part. So first we need to look at the forces in the x direction. We will have the normal wall exerting a force this way, as in this way, but we'll also be having the force of friction. And those would also equal each other to prevent the ladder from actually sliding down. So set that equal to 0. In the y direction, we see that the normal force from the ground is positive because it's pointing up, and the downward forces are actually the firefighter, 800 newtons, and the ladder itself, which is 500 newtons. So then the normal force given by the ground minus 500 newtons plus 800 newtons would actually equal 0. So in total, the force given by the ground is 1,300 newtons. Now you have to take into account torque. So first, if you look at this diagram, you see that the firefighter right here, and if you're looking at from this point here, the radius is moving up, but the force of the firefighter itself is moving down. So we see a turning motion like this, a counterclockwise force, and it's pointing out. So torque would actually be positive. So then, because torque is equal to radius times force, we would have the force times radius 4 meters sine 30. With the actual torque given off by the ladder itself, we see the same thing. The radius moves this way, but we see the force downwards, and it's counterclockwise, so torque would be positive. So 500 newtons times 7.5 meters sine 30. But if you look at the force given off by the wall, although the radius is going this way, we see that the force is actually moving out. So then torque is moving into the paper, which means it's actually negative. So this is indicated by the negative sign. The force of the wall times the radius, 15 meters cosine 30, and set that equal to 0. Once you solve that out, you should get 267.5 newtons. And that's it for part A. Now for part B, this is when the firefighter actually moves up, and he's now 9 meters from the bottom. Basically, you can solve this the same way that you did in part A. So torque is always equal to 0. So what you see here is that the 800, the radius moves this way, but the force is down, so still positive. 800 newtons times the radius, 9 meters sine 30. And then for this actual ladder itself, the radius moves this way, but the force is down. The torque is positive. We would see 500 newtons times 7.5 meters sine 30. Now the wall, although the radius is moving in this direction, the force is outwards. The torque, my thumb, is pointing into the page, which means it's negative. So that's indicated by a minus right here. If you solve that out, you should get the wall gives off a force of 421.47 newtons. Now, according to the problem, it says that if the ladder is on the verge of slipping, what is the coefficient of static friction between the ladder and the ground? What we see here is that the force of friction is equal to the coefficient of friction times mg. 421.47 newtons, which is the total force given off by the wall, and then the coefficient of frictions times 1,300 newtons, which is like the total force of the ladder and the firefighter. So when you solve that out, you get the coefficient of friction is equal to 0.324. And that would be how you solve number 11.